Now we are looking at properties of division. Means what, when we divide, what properties that division holds. We'll see one by one. If A and B, and such that B is not equal to 0, are whole numbers. We are seeing properties of division of whole numbers. So if A and B are whole numbers, then A divided by B expressed as A by B is not necessarily a whole number. In, let's say, take an example, 14 divided by 3, its value will come into the fraction, so it's not a whole number. So basically, or in other words, whole numbers are not closed for division. Closed means if we divide two whole numbers, we get whole numbers. So this is not the case in whole numbers. We may get or we may not get the whole numbers. If there was a thing that we divide, we get the division result as whole number itself, then we would have said that it's a closed for division, but it's not the case. That's the first property. Then so now the second property, if A is any whole number, then A divided by 1 is equal to A. In other words, we can say that any whole number divided by 1 gives the quotient as the number itself. So this is actually obvious, but when we say we are seeing the properties, this is a property. In many problems we will need this property. Next, if A is a whole number other than 0, then A divided by A is equals to 1. In other words, any whole number other than 0 divided by itself gives 1 as the quotient. So 12 divided by 12 gives you 1. Now fourth, 0 divided by any whole number gives quotient as 0. In other words, if a is a whole number other than 0, then a divided by 0, sorry, if a is a whole number other than 0, then 0 divided by a is equal to 0. Then fifth property, let a, b, c be the whole numbers and b is not equal to 0, c is not equal to 0. Then if a divided by b is equal to c, then b into c is equals to a. That's the relation. One means division is actual, other way around, it's a we can describe it in multiplication also. So like 12 by 4 equals to 3. So 4 into 3 equals to 12. Then sixth property is let a, b and c are whole numbers such that a is not equal to b is not equal to 0 and c is not equal to 0. Then if b into c equals to a, then a divided by b, a divided by c equals to b. A divided by c equals to b and a divided by b, equals to c. This is the property. Like 12 divided by 3 equals to 4. This is our a. Now a divided by so this is our a, this is our a, b and c. Okay, now a divided by c, 12 divided by 4 comes answer as 3, that is b, and a divided by b comes answer as 4, that is our c. So this is the relationship showing property. Now seventh, if a whole number a is divided by a non-zero whole number b, then there exists a whole number Q and R such that A is equal to BQ plus R, where either R is equal to 0 or R is less than B. So A is equal to BQ plus R. We will see this as, or we can express this as, A is going to divide by B, then we will get a quotient, or we will have a quotient Q. Then A minus B. And here Q comes to R. So this is a property. If a whole number A divided by a non-zero whole number B divided by A is divided by non-whole number whole number B, then there exists a whole number Q and R, that is quotient and remainder. And a remainder where R is equal to 0 or R is less than B. So let's see, we will do simple division here. 4 divided by 2, 2 2s are 4. This 4 means this 2 into this 2, and their minus gives us 0, right? So this is B, this is Q, this is A, and this 4 is B into Q, that is B into Q, 2 into 2, 4, and this is the remainder of this division, subtraction, this is R. So yes, if A is divided by non-zero whole number B, A, that is 4 divided by I will just change the color here, it's necessary. So let's say A divided by non-zero whole number B, that is 4 divided by B, then there exists a whole number Q and R, Q and R, such that A is equal to, that is 4 equals to B into Q plus R. Yes, it's true, where either R is equals to 0 or R is less than B. Correct. So this is the observation, or this is the property of that division. Thank you.